mining is such a big industry, usually when it comes into an area, it does have an effect, and hopefully that's a really positive effect on good jobs and helping the economy and maybe cleaning up some old pollution and being good for biodiversity. But that shouldn't be taken for granted. It has to be a really good conversation with the local people and obviously the environmental checks, because there will be land disturbance. You can't get away from that. So it's a big operation, and that really needs this multidisciplinary team to come together.
Welcome to State of the Earth, the podcast from the Graduate School of Environment and Sustainability at the University of Exeter, Cornwall. Here, we explore the issues shaping our planet's future and look at how we can make a positive difference through advances in technology, conservation science, business management, and more. I'm Sophie Crossley, your host for this episode, where I had the pleasure of speaking with Frances Wall, Professor of Applied Mineralogy at the Camborne School of Mines. Professor Wall is one of the world's leading experts on critical minerals and sustainable resource development. She specializes in technology and raw materials that are essential for global decarbonization. Her work connects the geology and processing of these materials with wider issues of responsible sourcing, circular economy, and public trust in mining. In recognition of her contributions to geoscience and sustainable resource development, she was recently awarded an OBE in the New Year's Honors List. We are thrilled to have her on the show, so let's jump into it. First of all, Frances, thank you so much for joining today. We are so excited to have you here.
Thank you very much for the invitation. It's a great pleasure to be here.
So, to get us started, we've previously covered some of the basics of mining and responsible mining on another episode of the podcast. But to ease us in, could you possibly paint a little picture for us of the role that mining is playing in the global transition to net zero?
Yes, I think I'll start by saying there's two fundamental things really that humans do. One is farming, food, and the other is mining for materials. And I think kind of the second one of that, the mining, maybe we forget a little bit because mostly that's far away from us. We're not seeing that every day, and yet it's absolutely fundamental for all the materials that we use that are not grown. There's a saying, if it can't be grown, it has to be mined. And another one, everything starts with a rock. And that applies equally, and maybe more so, and we'll get into that with the critical minerals part, to the technologies that we need to the transition to net zero. So if we want to have renewable energy, solar panels and wind turbines, if we want to have electric cars, then of course they all have to be made of something. And the things they're made of all start off in the earth.
Yeah, absolutely. And as you were saying that, another saying popped into mind, out of sight, out of mind, So many of things, like you said, are wind turbines, phones, cars, all of these things require materials. And to many of us, obviously, it's right in front, and we forget that it all starts with a rock, as you said. So a very big picture topic to look at. And I guess with that mind, from a slightly more pulled back perspective, is the idea of kind of circular systems and circular economy. So there are a lot of ideas that we can talk about within this area, but in your mind, what would a truly circular system for critical metals look like in practice, or what types of things should we be considering?
Well, in practice, I mean, maybe I should start in theory. I don't know.
Yeah, maybe theory might be better.
I'm going to start with a mix, actually, of in theory and in practice. Because one thing that slightly annoys me is the temptation that we all have to talk circular economy and then draw a beautiful round circle and show materials going round and round. We'll use them here, and then we'll just recycle them, and we'll use them again, and they'll just go round again and again in this perfect circle. But that doesn't really exist. And for many technical reasons, as well as practical and social reasons and all kinds of things. So I think the kind of economy, when we say we need a new circular economy for, well, really for all materials, but especially for technology, metals and things, what we mean is that everything has to start off in the ground. So you can't conjure materials out of thin air. So everything starts in the ground. Then it needs to be explored for and mined in a very careful, resource efficient environmentally and people friendly way. So that's what we call responsible sourcing to start with. So it actually benefits the people who are producing those minerals and metals. And then it's looked after through the next stages of materials manufacture, and it goes into then the component manufacture. And they're setting up their components and then the products ready for a long life and additional lives right from the start. And that's a really important part of circular economy. People think it's all about what we call the reverse loops at the end of life. But to ever get a really good one, you really need to be thinking about that right from the beginning. And then it comes to people like us who use the things or into industry, and then we need to be careful with them and to use them as long as possible and not keep just chucking them out the next 5 minutes the fashion changes or whatever. And then there might be models where they go off for somebody else to use. So selling things secondhand, for example, is a just easy example of that, but maybe more sophisticated models so things stay in use longer. Then maybe things can be remade, remanufactured, we call it, without taking them down to their constituent materials. And when you can't do any more, then you have to recycle and bring things back around. So really trying to keep things in a long time use, be super careful with our materials, much better than we are now. That's really what a circular economy is. So it's a careful economy, I think.
One of the things you said that I thought was really interesting is there's often a bit of a misconception in that people are working backwards, or they think they should work backwards in a circular economy when actually it needs to be considered from the outset. And I guess you have so much experience in the industry. Have you seen kind of the language around circular economy change? Is it kind of coming more to the forefront that we actually need to be starting at the start and not at the end?
I think it's really easy for somebody like me as an academic to say this. You just say, oh, it's called eco-design sometimes. You manufacturers, whoever you are, car manufacturers, phone manufacturers, whatever it is, this is what you need to do. But if you're really in that position, there are many other things on the list of things you have to do. You've got the cars, it's got to perform really well, it's got to be super safe, and you can't suddenly change the technology and risk problems when people are driving the car. So got to be really careful about that. And I'm afraid at the moment that the eco design probably comes quite a long way down the list of priorities. And so I would say that most people are not doing it at the moment. But we certainly see some things like some of the car manufacturer companies in the UK have got labs or plants where they're taking cars apart and thinking about what it really means to recycle or remanufacture some of the components, and how can they get much better at that recycling car step. And then that's leading them back into their manufacturing chain to think what they could do better. So I think it's coming, but it's actually quite a tough ask for manufacturers. And I would say going right back into the mining, yes, it's coming. Some things people have been doing for a long time. If there's a good product, say you're mining, or say I think of an example. Well, if you're mining copper, then copper mines in certain places like the Democratic Republic of Congo, they have good cobalt in them. Well, that's been sold for a long time, and people know DRC is the main source of the world's cobalt. So that's easy. That's a really good co-product with the copper. But there are other byproducts that people could sell, which take more, and maybe they need some new ideas about how to use them and so on. And that's a harder ask, and often the companies don't want to risk changing their business model, something that works, just to get a small amount out of some strange element they hardly ever heard of because somebody else says it's on someone's critical list. And so there's this business model failure there, and we need new innovative ways to help with that as well to get this real circular economy working.
Well, it's quite a complex kind of puzzle, if you will. There's so many different pieces that go into it across the entire supply chain, from, like you said, the manufacturing side through to the research side and the academic side. How do you find that those two areas overlap? Obviously, it's so interesting. I feel like you have such a view of everything that's happening and how everything goes hand in hand, or perhaps doesn't go hand in hand so much.
Yes, so the work we do often where I'm at Camborne School of Mines, obviously we're working right up the front end. Sometimes it's called the upstream part of the supply chain. And so, yes, we do a lot of work in collaboration with companies. Often they are what we call exploring and then developing deposits. So they want to know, first of all, what the geology looks like, and so what kind of size and shape the deposit is. How can they mine it in the future? Is it going to be worth mining? Is the very first question. Is there enough of the mineral in the ground? I mean, that's jolly hard. When you stand on the earth, you absolutely cannot see, neither can a geologist see what's underneath. So there's all kinds of clever things, from all kinds of geophysical techniques and testing the chemistry in the soil at the surface, and understanding the geology by scientific research that we do to help make these geomodels. And then we sometimes we say circular economy geomodels as well, so we can work with them and put on the top what are the potential byproducts and co-products. How does your mine, might it interface with other local industries, is a key question as well. And so we can help the company be more resource efficient at producing its minerals, because when you start to take a rock apart and take out the ore minerals that you need, that can be very complicated, can be some very beautiful but complex mineral textures in there. And that's the kind of research we do at the university, is telling people all about that, and then about what kind of clever minerals processing processes will take that apart in the most efficient way. So working with those companies all the time. And then when we do things where we're looking at this wider circular economy, then we're talking to other manufacturers and things as well. Maybe we're talking about where their raw materials come from, or talking to them about the models that they could use, working with colleagues in the business school to say these are the kind of case studies of other companies where they've been able to make money by doing good circular economy things. So yes, we do lots of different kinds of collaborations.
Yeah, absolutely. And, this kind of information and resource sharing is such a value part of keeping the conversation open to people as well. And I know you briefly touched on processing in some of what you mentioned. And for some of our listeners who may not be as familiar with the term, would you be able to kind of explain processing and it's one of the most complex stages, and perhaps why this is so difficult to work on in this area?
So mineral processing is a really key stage on a mine. So let me go back to what a rock is to start with. So rocks, as everybody kind of knows rocks, we see rocks, but rocks are made of minerals. So individual minerals are the constituents of the rocks. And then it's the minerals that are made up of the elements. So when we say, aha, we're going to go and mine lithium, then we're absolutely not. Lithium metal's not stable at all. There's nowhere on the earth where you can just go and get lithium metal. What we mean is we're going to look at a rock and see if it's got minerals in it that contain the element lithium. So here's the example from southwest England in Cornwall, where I'm sitting, and that has some granite, a very famous granite in southwest England. And in certain areas, certain small intrusions of that granite contain mica, a mineral called mica that's particularly rich in lithium. So there we are, there's your target mineral with your target element in it. But of course, that's sitting in the granite amongst all the other minerals, the quartz and the feldspars and other micas. So you have to dig that out of the earth, first of all, maybe drill and blasting, because rocks are tough, right? So you get that out, then off you go to your processing plant, and then you'll need to crush that rock to make it smaller, so it will separate out, hopefully, the minerals from each other. Of course, it never quite does. So you end up with grains of rock, and they will go into a processing plant. And then it's a really clever science. You have to think, are these minerals heavier than each other? Is one maybe more magnetic than something else? If I put it in a solution and make bubbles, and this is real, if I put it in a solution and make bubbles, will my mineral cling on to the bubbles? That's one of the most important mineral processing techniques throughout the whole world, called froth flotation. So you've got all these different techniques that you can use in different orders and things. And so you design that so eventually you'll end up with a bag of the mineral that you want. and the stuff that you don't want will, in a good circular economy, be going off to other uses. But I mean, for real, in practice, on most mines, a lot of that material will go off and form the hills of waste that you see around mines, hopefully to be all landscaped or used for something useful in the future as well. But your bag of mineral concentrate, that's what's at the end of the mineral processing. And then the next step, which is sometimes done on a mine, so coming back to my lithium mica example, that bag goes into a chemical plant where they have to somehow dissolve up that mica or roast it to make it effectively dissolve. And then you've got your lithium atoms and you make them into a product like a lithium carbonate or hydroxide that you can sell to somebody else to make the materials to make a lithium ion battery. So there we are. That took quite a while to say that, and that's what mineral processors do.
Yeah, well, it's a very, very complex topic, as you said. And also, on top of that, you've got I would imagine, quite energy intensive in the sorting, and then it's resource intensive in the fact that you need some really brilliant brains to be behind the scenes working on this too. So I can imagine that the conversations around streamlining the process as a process and then streamlining it as a source of carbon emissions and kind of generally other waste is incredibly complex. I guess, would you be able to give us an idea of kind of what it's like to have those conversations, or in effect, kind of how the conversation may or may not be moving forward with regard to sort of circular economy and decarbonization topics?
Well, on a mine, there's always a kind of a joke that the geologists, that's the people who actually look at where the ore is and define that at the first stage, and define what that resource is, don't talk enough to the mineral processors, so the people doing all the fancy things in the plant there. And so now there's actually a branch of science, and it's called geometallurgy, that can link up between the geology and the processing, and that, we call it process mineralogy, understanding how the minerals will behave. That geometallurgy, that's really important. And that's some of the work that I got really interested in, is actually looking from a geologist point of view at the ore itself and saying, well, is one type of ore, or rare earths I was working on, actually more environmentally friendly when it goes through that processing plant? Is one type of ore inherently better than another? Is there something we should concentrate on from the environmental grounds? Because a lot of what we see in the geology and the mineralogy absolutely is directly related to how much land you need to mine. The richer ores obviously need a smaller amount of land disturbance in general. What about whether you can actually get the resource out efficiently, or whether lots of your mineral will end up in the waste? And all of these kind of things. Are there health potential health problems with the ore? Is it radioactive? Is it poisonous? Does it contain asbestos? All of those kind of things. That's all relates to responsible sourcing. And there's the inherent properties of the ore, and then there's what you actually do, your behaviour to mitigate that. And I think what we found is it was usually a swings and roundabout situation, that there's no absolutely perfect ore for rare earths. They all have advantages and disadvantages, and so you have to work to mitigate those disadvantages and obviously use the advantages. So a disadvantage might be that maybe something doesn't need lots of energy because it's not a tough rock, but then maybe it needs lots of chemicals. So you'd need to make sure that you're buying low carbon chemicals if you wanted to keep your carbon footprint low, for example. So there we are. That's some examples of that relationship between the geology and the processing, and the
Yeah,
environmental performance as well.
absolutely. I mean, it sounds to me like it's so important that these things don't sit independently in silos.
Yeah.
My side is I'm more on the social science things, but the way that so many things overlap, if we kind of just stick to our own individual area, there's so many other key pieces of information that we would be missing. And I think mining is so fascinating because you have all of these really minute topic areas. You have the logistics of mining, you have the environmental impact of mining, the people of mining, and there's this whole other piece which we haven't touched on yet, which is the kind of cultural aspect to mining, because there's people working in the mines, and then there's the community around that. So perhaps shifting our perspective slightly a little bit. We're on Zoom right now, but we're both down in Cornwall, and there is a very kind of deep mining heritage here. And so if we could talk a little bit about, how the region is really kind of coming back onto the map today, whether that's more funding, reopening mines, and if you could just highlight for us a little bit more about the resurgence of mining, if you will.
Yeah, well, maybe first let me pick up on your point about the social sciences and the need to get everybody together to make a mine a responsible mine, because that's something we're having lots of fun in our Critical Minerals Challenge Centre research here at the university, where we were able to find a grant that we could apply for and put colleagues on it who are geologists, mining engineers, mineral processors, social science, ecology, finance and circular economy, and that's our postdocs make that team. And then there's the 15 or so academics that go with that. And we have some really super conversations, and it's really good to get other people's points of views, and really nice to sit there and say, I actually didn't understand that at all. What are you talking about? Or to learn some really nice new terms. And I think that's important, because mining is such a big industry. Usually when it comes into an area, it does have an effect, and hopefully that's a really positive effect on good jobs and helping the economy and maybe cleaning up some old pollution and being good for biodiversity. But that shouldn't be taken for granted. It has to be a really good conversation with the local people, and obviously the environmental checks, because there will be land disturbance. You can't get away from that if you're putting a new big plant or digging a hole in the ground or whatever it is. So it's a big operation, and that really needs this multidisciplinary team to come together. So yeah, so we're having lots of fun, and hopefully doing some good for our local companies and the civic, local council and NGO partners that we're working with as well.
Oh yeah, I can imagine being a fly on a wall in those conversations would be incredible. So many great brains in one room.
Yeah, so it's a really exciting time in Cornwall, because there are about 7 projects going forward who are exploring for lithium, tin, tungsten, and copper. And they are at various stages, from the early stages of exploration, when they're really thinking about the geology and probably taking a small drill rig out and drilling some holes, through to having pilot and demonstration plants and actually looking at how you can produce lithium compounds and refining that ready to go with the bigger, real big full scale operation. The South Crofty mine is reopening. That's the one that's reopening in the same structure. So that's having to spend literally years pumping the water out of the old mine and then refurbishing the shafts and so on, ready to get going. So that's looking for tin down in the deeper levels. And I think that's about the world's richest deposit of tin that isn't currently being mined. So with the tin price so high at the moment, so they're employing about 100 people already, and that should go up to about 300, I think, if they get going. So we calculate overall, if the projects like the tin mine, that the hard rock lithium, geothermal projects that have boreholes and they can take heat for electricity or just for heat and extract lithium at the same time, if all of this got going, then we think that would be another 2,000 to 3,000 direct jobs, and then you can probably multiply that by 3 by all the other jobs that there will be in the supply chain. And we have a big sector here in Cornwall of specialist companies who are actually already working on mines all over the world. So it's a bit of a novelty for them to be able to work for clients in Cornwall too, just like we can now step outside our back door and find lots of exciting research waiting for us to do. And it's obviously great training for our students and things. But yeah, so we're really connected to the local mining and minerals ecology, but also from Cornwall. We always now tend to forget a little bit, but we shouldn't. But we're really connected to that global mining and minerals ecosystem as well, because we have companies here that go out all over the world to help those mines with their production.
Yeah, well, it's so exciting in many ways also for Cornwall kind of to dig back to some of its previous mining routes, and to have that come back into the picture as well is very exciting. I know sometimes in some places mining can have a bit of a complicated legacy in communities. So as demand for minerals grows, how do you think kind of industry can rebuild trust and at least make sure they're operating responsibly within that sort of social realm as well?
We notice that because obviously we do work on the social side, and I've done quite a few projects doing that where we've gone and talked to people, not just in Cornwall, but in other places, especially in Europe, where our projects have been maybe trying out new exploration techniques and things. And so I think the first thing to say, it really does vary from place to place. So here in Cornwall, you've highlighted the heritage, and I think people feel proud of that mining heritage, and especially in the areas in the real the heart, the spine of Cornwall, where a lot of those people have been in Cornwall a long time, for generations, and they probably worked on the mines, their families and things. I think they certainly like to see mining come back because they know it will provide good jobs, and it's kind of a matter of pride, really. That's the great disappointment when South Crofty closed in 1998. What are the Cornish boys to do? That can kind of all come back, and that would be really, I think that would be a real moment when Crofty gets going. So that's there. But even in Cornwall, there are other people who've moved here recently who may even have an old engine house very close to them. But then, I think they're horrified when someone comes and says, we're just drilling in the field down the road here, because, there could be whatever metal it is that they're looking for under the ground. And they thought that was all long gone and part of history and not something that we do anymore. So I think we should never take that social license, as we call it, for granted, even here. And we can see overseas, especially in Europe, some of the projects have actually been stopped because the local people have been really anti having anyone exploring and potentially mining. It's the mining that's kind of scares people, but obviously they not daft to pick that up at the exploration stage and then say, what on earth's going to happen here? And they, if they really get going, they can mobilize and influence the politicians and stop projects. And we've seen that. So yes, you talked about mining gaining trust, and there are certainly lots of incidents around the world where mining hits the headlines when things go wrong. And so I think people do see it as an industry where things can go wrong and it can cause damage. And we can even see the pollution here in Cornwall from the old mines that was left, where the mining companies just went away and didn't clean up. And even up to the 1970s, they were doing that. So definitely mining has got to re-engage and gain that trust, so that it really can run a clean act and really interface with the local communities, so that it's a pleasure to have that mine as a neighbour and not a disaster. And I suppose it just has to, first of all, do it, show that it's doing it, and then we always say, oh, nobody listens, you've got to go out and talk to people more. And that's true, but it's all very well talking at people. It's really engaging in those deeper conversations. I think, you said you're on the social side, so you know this much better than me, I'm sure, is that it's really, it's that engaging with people. And that's some of the research that we're doing here locally as well, is looking at networking. So people tend to get jobs if they know about them, and that local networking from the old mining has been lost. So how do we get that back in place? I think it's more than just telling people mining will be a good thing now and we need this lithium and tin and tungsten and copper. That's not going to change people's minds. Probably just annoys them if you're kind of taking some high horse point of view, saying, well, don't be daft, people, we need these metals. And say, well, yeah, but not here, go away. So I think it's really those deeper conversations and partnerships, as we call them. That's what's really key to the social licenses, being in that local area and developing the partnerships with people earlier on, so that they can see that there could be something to their advantage coming with the mining operation.
Yeah, so well said. I think the word that you said that really stood out to me was engage, because it needs to be a two-way conversation, not just, a foghorn of
Yes.
preaching at someone else and keeping those communication lines open within local communities and the people that are working there. But it all sounds, there's a lot of excitement on the horizon then. And as we start to wrap up with a final question here, I would love to know, what are you feeling excited about in the future of mining? Is there anything in particular that you're looking forward to, you're excited to hear about? Anything coming down the pipeline that has you feeling excited for the future?
Probably quite a lot of things, because I have fingers in lots of pies of different research projects. Something we've started recently in our Critical Minerals Challenge Centre is actually modelling some different kinds of mining. So I think mining might go two ways in the future. We know that we'll have to mine deposits deeper under the ground. And so an underground mine is good, because the actual mining part of it's hidden. So it's very different to a quarry at the surface. I think that your underground mine could go in the way of some of the mines I've been to in Finland, where they're big caverns underground. You can just take even a tourist bus. I've been down in once, 500 meters underground to get to the mining area, and then their cafe and their lecture theatre and everything is all built underground, and it's actually, quite a nice environment. And then they go off deeper to actually do the mining, and a lot of that can be all robotic and so on. Or the other way to do it is what's nicknamed keyhole mining, is to think, well, let's not send people down at all. Let's try and do it from the surface and have something really clever that follows the mineral veins, or that takes a much smaller space underground and can sniff out the minerals we're looking for and munch them up and sends them back. And that's actually technically quite hard to do, but we're doing some modelling on some new ways and some variants on that. And I think that's going to be really interesting when we've done a bit more on the technical side, and then think about the biodiversity impacts and the people impacts, because it's not obvious that there will be fewer people aspects, impacts rather. And you might think there's bound to be from keyhole mining, but as soon as you disturb the ground underneath, you're going to make some really, really baby earthquakes. And if people feel something at the surface, that's something that we don't like. You think, oh no,
A bit alarming.
so yeah, so it could be. So obviously we don't. That's just what we are only doing this at a very conceptual stage. So I would say there's absolutely nothing happening. We're not doing any mining like that at all in Cornwall at the moment. It's on a spreadsheet model at the moment, but I think that'll be really interesting to quite early on test that on the people side, and see what people think to these different styles of mining that we could have in the future. So there we are. That's something exciting we're doing at the moment.
Oh my goodness, you've opened up a whole other can of worms there. I've got about 15 questions I'd love to ask just on that. But that all sounds incredible, and I will have to chase you up at some point to hear about the progress, because it's very exciting. So we are so grateful that you joined us today, Frances. I personally already learned so much. I'm sure it will be of very high value to our listeners. So thank you again for joining us, and we're thrilled to have had you.
Thank you very much. I've enjoyed it. Thank you very much indeed for interviewing me.